During a violent storm, fierce winds snap a high-voltage transmission line, sending it crashing onto the wet ground. The immediate human instinct is to turn and run, but in this specific environment, a normal running stride is fatal. The surrounding dirt is now the primary hazard. In a ground fault, the soil loses its status as a safe zero-volt reference point. Electricity has transformed the environment, turning a mundane patch of earth into an invisible geometric hazard zone. The earth is not an instant sink for electricity. When thousands of volts strike the ground, the soil acts as a massive resistor. This visualization shows ground potential rise. Energy expands outward from the strike point in concentric rings, like ripples in a pond. Voltage pressure decays exponentially as it moves outward. The pressure drops sharply with every foot of distance. A person can stand perfectly still deep inside this invisible voltage pond and remain completely unharmed. Surviving the voltage pond depends on avoiding differences in electrical pressure. The situation turns deadly the moment you take a walking stride to escape the zone. This diagram defines step potential as the difference in voltage pressure between any 2 points on the ground. A wide gait places your front foot in a lower voltage ring than your back foot. This creates a massive pressure differential. Electricity requires a pressure difference to move. This physical stance captures thousands of volts of differential. A normal human stride acts as a bridge across the invisible energy gradient. The human body is mostly water and electrolytes, making it a better conductor than the resistive dry soil beneath it. Current takes the path of least resistance. It travels up one leg, through the lower torso, and down the other leg. Many people assume that standard rubber-soled sneakers will act as an insulator and block this current. This demonstrates dielectric breakdown. Standard rubber is only rated for low voltage and is easily bypassed by the grid's high transient overvoltages. Standard defensive instincts and everyday clothing are useless against these extreme physical forces. Survival requires moving out of the hazard zone without ever allowing a voltage difference to exist between your feet. If your feet are pressed tightly together, they share the same voltage ring, creating an equipotential zone with zero pressure difference. You must slide your feet together in a constant shuffle. You cannot break contact with the ground or create horizontal space. Lifting a foot is a grave danger. The moment it touches down further away, the circuit reconnects across the air gap. Surviving a downed power line requires overriding the instinct to run and aligning your movement to the geometry of the grid.